winners only. And let's begin with a shot which will show you just how tough it is to get on this list. How about winning your first major with a birdie on the 72nd hole and lifting the monkey off your back?
Phil Mickelson. Yes, and at least a 10-inch vertical leap. That was the reason he got into the top 10. It was a vertical leap. But obviously an unbelievable moment in Masters history. And for Phil to finally get that first major championship was huge.
That was in 2004. Of course, we don't
yet the Masters. It either is coming up, or it is happening right now, or it just did. And it is an awesome time of the year if you're a golfer. If you're not a golfer, it means nothing to you. But anyways, here's the backdrop for this this video. We're doing section 8 of chapter 10, and the essential question really is going to be this. There's 3, but here as they pop up, you can see it says, how do you find the side lengths of a chord angle? Please keep in mind and note this thing right here. It is not asking you to find the measure of the angle that's a chord angle. That's a huge thing of what we just talked about. We just did a whole bunch of different questions and a whole bunch of different essential questions that was dealing with the measures of angles. This, guys, is not measures of angles. Has nothing to do with it. These power theorems, as we call them, there's 3 of them, deals with finding the lengths of the sides of these particular angles. But one of them is a chord angle. The other one is a tangent-secant angle, which is called a tangent-secant power theorem. And the last one's called the secant power theorem. There are only 3 power theorems that we talk about. And onto your foldable, here we go. So the power theorem number 1 that we're talking about is chord, and that's where you would write it, just like that. So the chord power theorem, open up your foldable. And what you'll see inside that foldable will be this. Well, at least you should. Oh, side note, check this out. Anybody know where that is? Yep, you got it, the Masters. Anybody want to know what? Anybody know what hole number it is? You got it. It's hole number 16. Maybe you knew it, maybe you didn't. It is a par 3, a very famous par 3. Not quite as famous as the other one I'll show you in a little bit. But there has been many miraculous shots. I'm not going to name who and or where, but there's been many miraculous shots on this hole. And what a beautiful course, man. How awesome is that? Anyways, here's what needs to go in your notes. This is Theorem 95. It's the chord power theorem. It says, given a chord angle, that just popped in there, it says the product, meaning multiplication, of the measures of the segments of one chord is equal to the product of the measures of the segments of the other chord. Woo! What a big old mouthful that is, it seems like. Chord angle. So you got this chord angle down here, and you got this whole entire side, if you will, that's the chord. And then here's the other chord. It goes down that way. Should have changed colors, but whatever. I'll change colors. Hold on. So this one. There's your 2 different chords. There's that one. Yuck. And then there's the other one. And there's different pieces that it's broken up into. You can see that this one right here is broken up into D and C. And this one here is broken up into A and B. Well, this chord power theorem, again, has nothing at all to do, guys, with the angle measure. We're not finding the angle measure here, or here, or here. We're finding the side lengths. And how do you do it? It tells you. You have to take the product of the measures of the one chord. So A times B equals C times D. That's exactly how you do it. Anytime you have a chord angle, that's exactly it. Now here's a simple example. Let's say you're given this chord little piece over here is 5, that piece is 9, that piece is 3, that piece is X. I agree it's not drawn to scale. But if you're looking for that little piece right there, straight up chord power theorem would say you take 5 times 9. 5 times 9 equals 3 times X. Then of course when you solve this, you get 45 for this side, 3x for that side, divide both sides by 3, and you get a whopping answer of 15 equals X. It is that simple. Nothing more to it than that. That's the chord power theorem. Okay? So let's rock and roll, and let's keep on moving. Here we go. Okay. So, check this out. Next power theorem. Anybody know what hole number this is? It's a different one than before. It is the green coming up on hole number 10. Why is that significant, you say? Well, my friends, in 2011, actually 2012, sorry, there was another miraculous shot On the sudden death hole, by the way, 10's a significant hole because it is the first playoff hole that happens if there's a sudden death playoff after the 4 rounds are over. But Bubba Watson, I just wanted to say the name Bubba. Bubba Watson hit an unbelievable shot into this green out of the right trees over there to the right that you can't even see. Unbelievable shot that actually made him win the 2012 Masters. Regardless, let's go to the next power theorem. I know you guys are like, okay, Motter, let's go. So we got chord power theorem, and now we got tangent secant power theorem. And if you were a betting person, which you shouldn't do that ever, but if you were a guy that or a girl that would wonder, I wonder what this picture is going to look like. I wonder what the angle is going to be. You're right, tangent secant. So here we go. The tangent secant power theorem. It is theorem 96 in the book. Tangent secant power theorem says, hey, if we have a tangent secant angle like you see down here, we got ourselves a tangent and we got ourselves a secant. Lovely. It says, oh boy, here we go. The square of the measure of the tangent segment, it's underlined for a reason, is equal to the product, meaning multiplication, of the measures of the entire secant segment and its external part. What is that all about? Well, you see this stuff, it's just flying in here. This A represents the tangent segment. This C represents the entire secant segment. In fact, this line over here should be underlined. Entire secant segment. So C represents that entire secant segment. And the external part is represented by B. The key thing here, guys, if you want to write this down, do so. Remember, highlight this, do whatever you need to, but entire secant segment is extremely crucial. That's the mistake that most people make. If I put this over here and label this as D, as just the chord length, a lot of times people will make the mistake and say, oh, I'm going to square A, and then I'm going to do B times D. No, 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 no. What you have to do is this. You'll see it popping up. It's the square, A squared, that thing right there, the length of the tangent segment squared, is equal to the entire secant segment. Entire secant segment. And the external part. This is exactly how it works. So if I gave you a simple question like this, where this chord is 12, the external part is 4, and I was asking you to find the tangent segment. Some of you might look at this and say, oh, okay, well, if I read this again, tangent segment is equal to the square of the measures of the tangent segment, that's this, equaling the product of the measures of the entire secant segment and external part. Some of you might say, well, there it is. So I square the tangent segment, I take 4 times 12, and I get 48 and rock and roll from there. Wrong, 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 wrong. Do you know what's wrong with it? Yeah, you're right. That 12 is incorrect. That 12 right there is not righto, because the 12, notice it's actually in the picture just the chord length. No sirree, Bob. You need the entire secant segment. Crazy. So what it should be is this. That's what it should be. It's 4 times 16, because 4 is this external part. 16 is the entire thing. Yeah. Now when you solve this, it would just be x squared, yeah, equals 40, whoops, 60. Let me make that a 6. It's a 6. It's an ugly 6, but 64. So then you square root both sides, which means x would be positive or negative 8, because when you take the square root of both sides, it's positive or negative, guys. But we disregard the negative. Why? Because I can't have a negative length of an angle. So the answer is just 8. So x in this particular example would be 8. Awesome. So we got tangent secant power theorem, and the last one we just did was the chord power theorem. So let's move on. What's next? Well, oh, do you know this hole, ladies and gentlemen? It is one of the most famous holes. Not kidding. If you know anything about golf, anybody that knows golf, it is one of the most famous par 3 holes in the history of golf. It is hole number 12 at Augusta. It's a very short par 3, most around like 130 to 150 to 160, but it is one of the toughest holes in golf. I know it seems weird, but if you ever watch it, you'll see, man, guys just mess this hole up all the time. It's actually coming around what they call Amen Corner. There's a couple holes right around that corner right there. It is awesome. Anywho, means nothing to some of you, but it means a lot to me because it's actually pretty cool, and I can't wait to play at this course someday. It's going to be awesome. Anyways, let's go on to the foldable for the last power theorem. We got chord power theorem, we got tangent secant power theorem, and oh yeah, if you remember from the very beginning, it's secant power theorem. You got it. It's going to deal with the secant angle. So here we go. Here's the actual theorem. It's Theorem 97 in your book, and it says, given a secant angle, just like this one that drew right there on your screen, secant angle. Here we go. Look at all the words of this. Holy moly. So it says the product, meaning multiplication, of the measures of one secant segment and its external part. So one whole entire secant segment and its external part is equal to the product, meaning multiplication, of the same idea with the other secant. With the other secant segment, that should say the other entire secant segment. Same thing up here. This should say the measure of one entire secant segment, the whole thing, and its external part. I wish I could type that in there. You should write that. So it should say this. Given a secant angle, the product of the measures of one entire secant segment and its external part is equal to the product of the measures of the other entire secant segment and its external part. So what you're seeing right now is A is the external part, B is the entire thing, C is the external part, and D is the entire thing. So the equation should look like that. It is A times B equals C times D. So that is exactly the power theorem that's going to, again, notice this is not, I didn't say this in the last power theorem, but we're not finding this. We're not finding the angle measure. That's a different theorem altogether. This is power theorems dealing with side lengths. So let me give you a little bit more of a tougher example. So let's say this is our secant angle. We got the external parts being 3 and 5. Yes, it's not drawn on the scale either. That little piece right there is called 10. Well, it's not called 10. It is 10, a distance or length of 10. The question, though, is to find AB. That piece right up there. Well, how do I do that? There's two ways to do it. I'm going to set it up and you can finish it. But here's the scoop. You could do it this way. You could say, if I let AB, exactly AB, BX. Well, according to the theorem, go back in your notes and check it out. It says the product, meaning multiplication, of the measures of the entire secant segment, that has to be represented by 3 plus x, according to the way that I labeled x up there. 3 plus x. There we go. The entire secant segment is 3 plus x times its external part, which is 3. So that's the one side. So the product of the measures of the entire secant segment and its external part is equal to the product of the measure of the entire secant segment, which is 15, times its external part, which is 5. So there is one option that you can do. You'd have to distribute to 3. Yep, distribute to 3 through there, and then multiply all this stuff out. But that's one option that you can do. Pause the video right now and see if you can solve it for x. Well, I know you can. Okay? Hopefully you're back and you paused it and you tried it. But here we go. Let me show you the other way to do it. So let's say instead of letting AB be the x, why don't we do this? Why don't we let this entire thing here, the entire secant segment, AC, why don't we let AC be x? Let's do that. Why would you do that? Well, you could do it the other way like I just showed you, but watch this. Let's now use the secant power theorem. It says the product of the measures of the entire secant segment and its external part, that would just be 3 times x. Lovely. Is equal to the product of the measure of the entire secant segment. This guy. Nope, that's not it. Sorry. 15 is what it would be, the whole thing. That guy, 15. And its external part. So that's 15 times 3. Now, which one's... Whoops, sorry. It's 15 times 5. That's ugly. 15 times 5. Which one's easier? The one I just showed you where we let A, B, x, and then we did 3 plus x, and I don't know, whichever one you want to see. But just know the secant power theorem deals with the entire secant segment, not this little chord up there. So you just got to be careful with how you label it and what you know the theorem is telling you. So, what did you get for the answer, by the way? If I solve this one out, I get 3x, whoa, equals 75. And then when you divide 3 into that 75, you would get 25. Wait a minute. That's probably not what you got in the last one. And it shouldn't be. Because you would have got 22 if done properly. And you might be thinking, so where's the 22 come from? Well, remember, we let up here in this example x be AC. That means this entire secant segment, that entire secant segment, when I just let x be, is 25. That's not my answer. The question was actually asking for AB. So I'd have to take 25, the whole length of the secant segment that I found, and subtract away this 3, which would leave me with my answer of 22. So which way is better? Don't know. Both ways you get the right answer. You just got to know what you're getting when you get x and what you're letting it represent. So there you go, guys. That is the power theorems, ba-bam, chord power theorem, tangent secant power theorem, and secant power theorem. So there you go. There's your master's flag. We're throwing in the flag. Game over. I'm excited to help you guys in class with these later.